Let's get started.
Yeah.
Yes, my screen is visible.
Yeah, better.
Okay. So we are going to learn about why we need a Kubernetes. Okay. So Kubernetes is being a buzzword in the current IT industry. Okay. In most of the places, this Kubernetes is being used. Okay. And we are going to just to know about why we need a Kubernetes. Okay. Right. So before starting with the technical session, I would like to convey about our community. So our Cloud and Loud community is an 11 years old community where we help on the technical front, okay, for all the technical aspirants, and also we are helping the cancer children in terms of the financial. So we are also in a motive, so there should not be any cancer survivors. Okay. So whatever the revenue which we are getting it from this community, we are sharing the same with those people. Okay. So starting with this why Kubernetes. So in the years of 90s and 80s, how the an application is being delivered. Let's say when we have a application. So just for an example, I have an application here. Let's say this Facebook. Okay. So how this Facebook was delivered in the terms in the years of 1991, 1992, and all those times. So we were having the each and every component of the application in a separate servers. So if we are using the Java, so Java will be installed in a separate server, and the DB will be installed in a separate CPU, and the web server will be installed in another separate, and log server also in the separate. So to monitor the transactions. So at the time we were having the compatibility issues, like if you want to have a Java will be running on Windows machine, database will be running on the Linux machine. So at the time we don't have a provision to install dual OS in a single server. Okay. And due to that compatibility issue, where we are in need of maintaining a separate service for each and every component of the application. And moving on to the in the early ages in the early years of 2000, okay, where we were having a single server. In a single server, okay, we were installing another major technology called as hypervisor, that is the virtualization. Okay, virtualization got into boom around the 2000. So whatever we were maintaining in a separate server, okay, we were able to bring all that under a single physical server. Okay. So here what we have been doing is, in a single machine, as a base OS, we may install Windows or Linux. Over it, we will be installing any of the VMware technologies. Okay, VMware technology, VMware software, or Oracle VirtualBox, which you might have came across. And using this we will be creating the VMware instances. So Java instance, DB instance, web server instance, and log server instance. So in the previous slide which you would have seen, so we were using a separate physical server, and after a virtualization came into the market, we were installing as a separate individual instances. Okay. And that's how this hardware capacity or the hardware component which made little easy when compared with the previous one. Okay. And around in the year of 2010, okay, then Docker came into the market. Okay. So how the using the Docker engines, we were able to create the containers. Okay. When we have any Docker engines, we can able to create the containers. So here we were not dependent of a hypervisor or a virtualization. Okay. This Docker has totally eradicated this virtualization. Okay. So having any host operating system, we can install a Docker engine, and over the Docker engine, we can create n number of containers as per our physical server capacity. So in this physical server, we will be creating multiple containers as per our requirement. Let's say this application one in need of a Java server and the MySQL database server. So we will be creating a respective containers. And for other application, I need .NET server and MongoDB server. I will be creating the same. So likewise, we can create n number of containers according to our requirement using the Docker. Okay, right. So as the days goes on, so people were creating multiple containers in a single server. Now the problem statement here is when we are using a Docker, we are creating multiple containers. But when the number of containers are increasing, how we will manage it? See, managing a 10 people or 20 people is easy, but same time managing 1,000 or 2,000 people, so we need some more administrative tool, right? So on that front, so people have come up with the more orchestration tool to maintain these containers. Okay, to maintain this container, that is called as a container orchestration tool. That is, one is from the HashiCorp Nomad, and another one is from SUSE Rancher, and another one is the Docker Swarm. So these were the container orchestration tool in the earlier times, okay, which people have been using it. Okay, but see, orchestration in the sense like when we are delivering an application where we will come across storage, networking, patching, and security vulnerabilities and all those things, so how we can able to maintain all these things into a container. Okay, to maintain these parameters, we need a very good orchestration tool. Okay, and due to that these Rancher, Docker, and Nomad were not able to serve as much as the for the part of the business requirement. Okay, and there it comes our hero, the Kubernetes. So Kubernetes were satisfying most of the business requirement in terms of container orchestration. So Kubernetes was found by Google in the year of 2014 or 15, I guess. Okay, and using a Kubernetes, people were able to maintain the operations of the containers requirements very smoothful. Okay, so now I'm getting into the Kubernetes architecture. Okay, so I'm just giving a layman example over here. So now let's say consider in the sea we will be having some cargo ships and a control ship. So what this control ship will do, this control ship will decide which container should goes to which cargo ship. Okay. So it is like an admin, okay, where it will not carry the container, but it will give instructions according to the availability and scalability. It will be giving the instruction which container has to go to which cargo ships. So likewise, the container will be loaded in each of the cargo ships. Okay, so now coming on to this actual Kubernetes architecture, the cargo ship is nothing but the worker node. Okay, so here in the Kubernetes architecture, we will have one master node and a multiple worker nodes. Okay, we will have one master node and one multiple worker nodes. Okay, even people will be having 400 or 500 worker nodes in the real time. Okay, so what this master node will do is the master node will be act like an admin, and where it will be keep on monitoring all the worker nodes. Okay, regarding it, the health wise, it's a traffic wise and everything. Okay, that's the purpose of the master node. So even in the worker node, we will be installing the Docker, because using the Docker only the containers are getting created. Okay, so in the master node, we have one important component, that is the Kube API server. Kube API server is the important component, or I can say the captain of a ship, which will be monitoring all the worker nodes, which will be monitoring, okay, and also communicating with all the worker nodes. And then we have another important parameter in the worker node, that is called as a kubelet. Kubelet is the captain for the worker nodes. Okay, so through the kubelet only, all the communications will be communicated to its master node. Okay, so that's what here I would like to convey at this point. And then in the master node, we have another important component called as etcd server. Etcd server, it's like a database. database in the Kubernetes. So whatever the transaction which is happening, so that should be saved somewhere else, right? So all the metadata, all the Kubernetes metadata will be saved in the etcd server. Okay, and then the control manager. In the control manager will control the worker nodes in terms of under the control manager we have n number of we have n number of controllers like node controller, replica controller, something like that. Replica controller in the sense, so if I want for a particular application I need a replica count of 2 or 5. Replica is nothing but a copy, clone. If I'm creating a one container, that container should be cloned to 5. Okay, so those kind of tasks will be carried by the control manager. And we have another important component called as the scheduler. Okay, scheduler will schedule the containers to go, which container has to be resides in the worker node. Okay, so that is the use of the scheduler. Okay, right. And the next point here it is to convert to communicate to the master node. We have kubelet and kube API server. How the worker nodes will be communicating? Okay, when we have n number of worker nodes, so what is the internal communication between the worker nodes? So for the worker nodes, we have another major component called as the kube proxy. So within the kube proxy, each and every worker node will get communicated. Okay, so these are the main important components of the Kubernetes. Okay, so the previous example what I have shown is it's like something like the layman example, and this is the Kubernetes HLD which is being used in the real time. Okay, in all the IT organizations, this is the HLD. So where you can able to see one master node and you can able to see multiple worker nodes. Okay, we will have n number of worker nodes. So each and every node will be communicating with each other, where you can able to see only one pod inside the worker nodes. See, the reason is when I'm spinning up, when I'm creating an application, okay, in terms of a pod and a container, the particular pod will be having a replica of four, and all those pods will be scattered in the each worker node. The reason being here is it is going to serve the same traffic. Okay, the reason is if worker node goes down, the application traffic will be served from the another worker node. So that is what here when we are creating an application, that particular application pod will be available in the all the worker nodes, not in only one worker nodes. So that is the job of a control manager here. Okay, so likewise here we will be having the n number of pods in each and every worker nodes. So this worker node is nothing but a physical machine, or okay, physical machine, or the EC2 instance, which we can say in AWS is the EC2 instance, or in VM instances in GCP likewise. So based on this worker node capacity, we can able to create n number of pods. Okay, so when it comes to the Kubernetes services, what is available in the market? Okay, is this Kubernetes services is being provided by the Red Hat. In Red Hat, there is a tool called OpenShift. Okay, that is called as a Open OCP. Okay, so majorly in people with the financial services or banks, they are using the on-prem data center, and they are using the Red Hat OpenShift container platform. And as from Amazon, we are using Amazon EKS for this Kubernetes. What we can say, people have already hosted their applications running on the Amazon, and if they want to use the Kubernetes services, people are started using the Amazon EKS. And when it comes to the Google, in Google also we have Google Kubernetes engine, okay, to serve for this Kubernetes services. And also in the Azure, we have the AKS. So in all the major platform, we have the Kubernetes services. In most of the organizations, people are using it according to their business requirement, according to their budget, okay, and according to their governance call, that is as per their government policy, they are using the each and every services based on their requirement. Okay, guys, I'm done with my session. So if you have any questions, you can ask. So it's time for the question session. Yep. Please feel free to ask the questions.
No questions, bro. Fine, really nice.
Okay, Vida. Thank you.
Yeah, for architecture wise is really nice. I have one question. How long
Right.
it take to make the presentation? Is I can feel it's a really need a huge effort.
Yeah, it was a
So
huge. It was a
yeah,
huge. It was a huge effort. Yeah, but I didn't calculate the timing. To
yeah.
be frank.
I can give one suggestion.
Yeah.
Next week or when you get the time, make this session in the LinkedIn. Okay.
Sorry.
So in LinkedIn, make this same kind of
Yeah,
session
yeah.
in
I have posted in LinkedIn also.
like I'm saying LinkedIn events.
Event. Ah.
Yeah,
Oh, okay,
because
okay.
it's really nice. We can tag many the CNCF leaders also we can tag.
Sure,
So
sure,
if
sure.
they joined,